This is a short video about centripetal force or centripetal acceleration, which is very important in gravitational bodies, but also in basically anything moving in a circle. So, if we take, for example, the Earth, and the Moon is moving around the Earth at a constant speed. However, its velocity is changing. Okay, delta means changing. The velocity is changing because it's constantly changing direction. And as we know, velocity is speed in a given direction. So a change in velocity in a certain amount of time is known as acceleration. So we can say that the Moon is continually accelerating because it's always changing direction and therefore changing its velocity. Now, this is important because we say that there is a centripetal force which acts towards the Earth. The name of the centripetal force in this case is gravity. Gravitational field will pull the Moon towards the Earth. All right, but we can take a lot of different examples of things moving in circles, and it's a very similar deal here. So centripetal force, which is obviously measured in newtons, pulls the Moon towards the Earth. Now, things that will affect the magnitude of this centripetal force. If we change the radius, how far away the Moon is, that will affect the force between them, the centripetal force. If the Moon was too far away, it would need to be moving at different speed. Another factor, or should I say correctly, velocity. If the Moon was going too fast, the Moon would spiral off. The last thing that affects it is also the mass. Because gravitational field is affected by the mass of the two objects, the force of attraction between them is affected by the mass. If the Moon was too heavy, it would spiral off out of control as well. So, at any point, if you want to figure out which direction it's going, you simply draw a tangent to the circle. So let's say the Moon was revolving around the Earth and all of a sudden gravity for some bizarre reason disappeared. The Moon would go flying off at this angle here, a tangent to the circle. Same thing, if it was released here, it would go off at a tangent to the circle if that gravitational force suddenly disappeared. Now, if we ignore for the fact that this is the Moon and the Earth, we can apply lots of different examples. Let's say we have a man in the Olympics and he's throwing the hammer. Okay, so let's see if we can link this up to his hand. So he's in the Olympics, they move this hammer, the hammer throw in the athletics, round and round. If he was to release the hammer at this point here, it would come off at a tangent there. If we make the chain longer, it changes the size of the force. If he wants to move it faster, that would increase the size of the force. He'd feel more of a pull here. And if we make the hammer heavier, that would also be more difficult. Okay. One last example that also works. We can have an example of a parent who is moving their child round in a circle, like all kids want you to do. So hard work for the parent. It becomes harder if he pulls his arms in towards while he's moving the child round and round. If he wants to move the child around faster, which children always want, that's going to be more of a force here. He's going to need to exert more of a force here. And also if the child is heavier, it becomes harder. So centripetal force depends on radius, velocity, and mass.